And the assignment operator will be a ampersand operator equal to, so in C++, this is a function. Operator equal to is a function where you say const a ampersand other. Okay, so this is the default assignment operator. Okay, and what would be the content of this? This is going to simply copy a int equal to other dot m int, then m ptr to int equal to other dot m ptr to int, and then it will also invoke mb. Remember, the mb was the class. It will invoke the copy constructor corresponding to that. So other dot mb, not copy constructor, sorry. This is equivalent to writing mb equal to other. So this is the assignment operator, not copy constructor. I'm sorry. There's no difference between, I mean, this is just another style of writing. And then finally, it's going to return. It will return star this. So what is this pointer? So when you have a class and you are defining some function. So let's say you define void foo and you passed in, let's say, value x, right? Every function is always having an invisible argument, which you don't see it. And that is the this pointer. So the invisible parameter that is always existing, that you don't see it, it goes like this. It's going to be of type A, okay? But notice it's going to be the A star const this. So this is a const, I'm sorry. Let's be clear. So A is a const. So pointer const this. So what is constant here? The constant is the pointer. Okay, so this is a const pointer to A, because this is supposed to point to the object, right? It points to me. So when you do a, right, and when you call a dot foo, right, so inside the function foo, so suppose in this case I'm passing parameter, right? So let's say int y equal to 6, right? So you pass y, right? So okay, y gets passed through x, but there is also this invisible pointer, this gets passed in. But what is this? This is basically same as this ampersand a, or the pointer to this object a. So in other words, this is what is actually myself, because when we are calling a dot foo y, then essentially I can refer to every private member. So let's say int a inside, right? So I can refer this a equal to 6. So either we can write it like this, or you can drop it, because when you are dropping it corresponding to the member variable, there is always this pointer coming into picture.
So I have a question. So this is just a pointer to other in the example of the default assignment operator?
No, The this is basically pointing to this class, this class, sorry.
Okay, so it's pointing to, sorry, it's pointing to a class, not an object.
Yeah, basically whichever class this particular member function belongs to. So it belongs to this A. So therefore, I mean, more specifically, we can say like the particular instance which is invoking this function, right? So that this corresponds to whatever invokes it. Like for here, the foo gets invoked through this object A, right? So therefore, this pointer is the address of A. And therefore, when we are referring to A here, we are referring to all the variables corresponding to this guy, right?
Okay, yeah, that makes sense.
Makes sense? Okay. So now here is one important detail. So now there is another way of adding const here is by adding a const here, you know, at the end of the function. So when you add a const here, this const actually gets placed here, you know. So it has the effect of doing a const star const this when you are placing a const after the function. So this is now a const member function. And when would you like to do this? When you want to make sure that there cannot be any assignment to any of the member variable. Because what is const here? The pointer is const as well as the content of the pointer, which means that you cannot write this a equal to 6 inside anymore. It can be only read, it cannot be written because it is applied here. So it's now const pointer to the const a, and therefore you cannot change any of your member variable inside. Is this point clear?
Wait, so that goes in the parentheses as well after integer?
Invisibly. This is invisible. I'm just explaining to you what happens under the hood.
Wait, but the constant after, don't you have to put that explicitly if you want it to not be able to change the
one you are putting
member function?
Yeah, this is the one that you are writing, but this is the effect. This is the effect. This is not what you're writing.
Okay.
This is behind the scene. Now you can understand why this has been defined to be const pointer to a, because you don't want anybody to write here this equal to 0x5000. That would completely mess up your program, right? And that is why the definition is always carrying a const pointer to, so that it's the pointer that is constant, which cannot just assign to anything. And that is the rationale there. Okay, so the assignment operator, as you can see, this is returning star this, which means the content or the dereferenced value, that is what is returned. So this is important. Why does it return? It returns because you can write a equal to b equal to c in your program, right? So the assignment operator gets first invoked for this, right? First gets invoked for this. And whatever this guy returns, it then acts as an argument for the next. So you can do operator chaining. And that is why this thing returns a value. I think I placed this in a totally wrong place. Sorry about that. I wanted to place here. The scoping operator belongs to the function. Here the function name is operator equal to, okay? This is the return value. And you can see that it is returned by reference. You can see that, right? So there is no copy overhead when it is returning. I think I probably overloaded.
I have a question.
Yes.
If you're returning the dereferenced value, why is it a ampersand? Because isn't that an address?
Remember, this is a reference. This is not an address.
Oh.
Right? So
I'm
don't.
still confused about that. Okay.
Two utilities. Okay. It is very contextual. When the ampersand is following a type, that's a reference. When ampersand is preceding an object, that's an address of operator. So let's not get, because it for some reason we have used in the C language or C++ language the same ampersand operator, so it can be confusing, and that's why I'm clarifying this. So don't confuse address of operator with the reference. Okay. Any questions so far?
What is the purpose of the assignment operator?
Purpose is when you are writing, let's say you have defined, that's why I asked, remember the copy constructor question. If suppose you have defined A and A, B, right? Here the default constructor gets called, right? Here another default constructor gets called. And then you do A equal to B. Here, what is going to be called? This is equivalent to writing like this, operator, because this is a function. This is the function name, operator equal to, calling B, but you're calling on A dot. So these two, so when you are looking at this, this is not a naive sort of equal to sort of operation when it comes to objects, right? Behind the scene, this is what is happening. Is that clear?
Yes, thank you.
Okay, and therefore you should not also confuse with, if I have written A here like this, and I write AB equal to A, then this is not going to invoke assignment operator. Okay, I'm repeating this just for clarity. Here copy constructor will get called.
So will default constructor be invoked for B, or only copy constructor will be invoked?
The default constructor is here. The
But
will get
when
called.
B is defined, like when you write A, like the uppercase A and B equals A, and you said it invokes copy constructor, does it first invoke
No,
the default constructor for B and then
no.
the copy constructor, or it directly?
That is why
invoke?
it's called copy constructor, right? It is constructed through copy.
Okay, thank you.
Whereas for the one above, it's the assignment constructor.
Which one?
Or sorry, the one on the left here. I guess.
Yeah.
Okay.
So this is invoking default constructor. This is invoking default constructor. This is invoking assignment operator. But when you have A, then B equal to, so whenever you are actually putting this, right, you're constructing something, right? But when you're constructing something by putting an equal to, that means you're constructing through copy. Okay, that's the way to see it. And another way of invoking the same thing would be this. And another way of invoking this would be this. These are just another syntactic sugar of invoking the assignment operator. So this is also going to invoke the assignment operator, by the way. This is going to say A dot operator equal to calling B. It's exactly the same thing.